Hi, Jin. Daniel misses you very much. He wants to FaceTime you constantly.
Maybe. But
What do
I
you
don't
mean
want to FaceTime with you.
You just said you want to FaceTime him. Hey, stop pushing the desk forward. You're gonna knock my phone off. Okay. So, today we'll be talking about properties of rational exponents. And you are probably already familiar with a lot of these properties, but it's always good to brush up on them. So first, if we imagine we have a raised to the power of m that's multiplied by another a, but this time it's raised to the power of n, so they share the same base, and this is product of power property. What do we end up getting?
A m plus n.
A raised to the power of n plus n. Very good. And what do we call this again? Product of power. Yeah, we're multiplying two powers. Okay. And if we have power of a power, so now we have a raised to the power of m that's raised to the power of n again. What do we get?
A n m.
A raised to the power of n times n.
Power.
So we call this power of a power product, right? We have a power and then we're raising it to another exponent, so creating another power. And then we have a times b raised to the power of m.
It is the power of the product.
Yes.
Okay.
Power of product. Power. So that would be, what do I end up getting? A raised to the power of m
bn
times b, not bm, but b raised to the power of m.
Power.
What? And then if we covered this yesterday too, but if we have a raised to the power of negative m, how can we change it to positive exponent? A raised to the power of negative m, how can we change it to positive exponent?
Root.
Root? No root needed. 1 over
square m square a.
What?
No, am.
1 over a raised to the power of m. Very good. And if we have a raised to the power of m divided by a raised to the power of n, so we have quotient of power. What do I get?
A m minus n.
Very good. And then if, let's say, we have a power of a quotient, so a over b raised to the power of m, then what do I get?
A power of
raised to the power of
m b raised to the power of m
over, right?
Yes, over.
A raised to the power of m over b raised to the power of
m.
Good. Okay. And since we just covered the properties of rational exponents, we should take a look at properties of radicals as well. So we have two different properties. One is product property, property of radicals. And then the second one is quotient property of radicals. And both are very straightforward. Basically, if let's say we have a times b that is in nth root. So essentially nth root of a times b. What does that equate to?
N square A.
Nth
N
root
A
times
nth root B. We did it.
Very good. And then the quotient property of radicals would be, stop looking at my notes. Similarly, it's for the quotient. So if we have A divided by B and it's in the nth root. So what is the nth root of A divided by B?
Okay, I can answer very strongly. Nth root A over nth root B. We did it. We did it.
Very good. It's fairly straightforward, but it's always good to brush up on this. So let's go ahead, take a look at page 41 and try some of these questions together. Okay, so we are simplifying the given expressions, and the first one is 7 raised to the power of 1/3 times 7 raised to the power of 4/3, and this is obviously product of powers, so we just have to add the powers together, and then we would end up getting 7 raised to the power of 5/3. Moving on to number 4, we have 5 raised to the power of 1/4 times 3 raised to the power of 1/4. Now over here, the thing is we have different bases, right? We have base of 5 and 3. So what we end up getting is we would multiply the bases. So we would have 15 raised to the power of 1/4. Number 7 is 11 over 4th root of 11. And that can be re-expressed as 11 over 11 raised to the power of 1/4. And this can be then expressed as 11 times 11 over negative 1/4. And we would just end up adding up the exponents again. So we would get 11 raised to the power of 3/4. Number 10, we have 54 over 64 raised to the power of 54 raised to the power of 1/3 over 64 raised to the power of 1/3. And you can go ahead, simplify them if needed. So 64 raised to the power of 1/3 just would be 4, right? Because 4 cubed will give us 64. And 54, or cubic root of 54, you can go ahead, factorize it, and what you would end up getting is 3 times 3 times cubic root of 2. So that's what we would end up getting. It should be a cubic root, not square root. So make sure you put a little 3 in front of that root 2. X raised to the power of 5/3 times x raised to the power of 4/3, and we would end up getting x raised to the power of 9/3, which can be simplified to x cubed. Number 16, we have x squared over 27, and that is raised to the power of 1/3. And that could be simplified to x raised to the power of 2/3 over 27 raised to the power 1/3 would be 3. So we would just end up getting 1/3 times x raised to the power of 2/3. And then moving on to number 19, we have x raised to the power of 7 over 5 divided by x raised to the power of 4 over 5. And that could be simplified to x raised to the power of 3 over 5, because 4 over 5 would give us a negative exponent. So if we add up 7 over 5 and negative 4 over 5, we will get 3 over 5. And lastly, number 22, I have x raised to the power of square root of 2. That's again raised to 3 and then square root of 2. So this can be simplified to x raised to the power of 3 times 2, because we would multiply 3 square root of 2 and square root of 2. So we would just get x raised to the power of 6. And that's it. Simple.